This is another short chapter, so we are pretty much at the end of this chapter. Let's look at some of the divisions in the marine environment. We talked about benthic species, pelagic species, and we said benthic species comprise 98% of all marine species. The marine species themselves are only 14% of the total number of species. Most of the species, 86%, live on land, and so on. So the marine environment is divided into pelagic, open ocean, which has neritic and oceanic. Neritic is basically less than 200 meters, which is generally the shelf area, and benthic, which is the seafloor. It has subneritic and neritic, so the biozones, here it is. The pelagic environment goes all the way into the open ocean, so it has the oceanic province going from 200 meters, which typically coincides with the shelf break. So the topography begins to get very steep over the continental slope as you go away from the continental shelf. So this continental shelf area is called neritic province. And then you have obviously impact of tides. So you have the low tide line and the high tide line, which are called sublittoral and subneritic and so on, and supralittoral. I don't think you have to remember all these things, but just look at them once or twice to make sure. You have the inner continental shelf, outer continental shelf, but these are important. Here also you have bathyal and abyssal and so on, but these are the important things you want to remember. These are epipelagic, the upper ocean, mesopelagic or mesopelagic, however it is said, goes from about 2,000 meters to 1,000 meters. It's called the twilight zone of the ocean. And then you have abyssal ocean or bathypelagic ocean. In terms of light, we look at light that is sufficient for photosynthesis. So we call it the euphotic zone, where there is sufficient light for photosynthesis. Typically goes down to about 100 meters, depending on. In fact, if you have too much biological production, then that phytoplankton itself shades the ocean below it. And if you have clear water, then you have light going much deeper, right? So you can immediately go back to your knowledge of the tropical Pacific, for example. In the east, we had Ekman divergence, upwelling, cold temperatures, and so on. When you have upwelling, you have more photosynthesis, more phytoplankton. Phytoplankton can block the sunlight from going below, whereas in the west we had warm waters, deeper thermoclines, clearer waters, so the light penetrates much deeper and so on. So below the euphotic zone you have the dysphotic zone going down to about 1,000 meters approximately. It depends on, again, how clear the water is. There are water quality parameters, water quality type 1, type 2, and so on and so forth. Depends on whether you're in the coast and a lot of organic matter is coming in, etc. Then below that you have basically no light, so it's called aphotic. So in the dysphotic zone you still have some diffuse light, okay? And we actually don't know how much life there is at these depths. So all the way down into the zone called Hadal. Always remember, Hades is hell. The Hadean was the earliest part of the Earth's geological era, and this is related to the same thing, Hadal. Okay, so quickly we'll go through the profiles we have seen before. We've seen the oxygen profile before. We have well mixed density mixed up in the top, what we call the surface mixed layer, where turbulence caused the temperature and salinity and density to be fairly well mixed. There are details, like when it's freshwater capping, then salinity is different than the temperature in terms of the mixing and so on and so forth. Photosynthesis happens, and atmosphere is mixing up into the ocean, so you have high oxygen, and heterotrophs begin to live below the surface to find food. They respire oxygen, so oxygen becomes minimum in the oxygen minimum zone, OML or OMZ, or oxygen minimum layer, or oxygen minimum zone. And here is a tricky question: why does the oxygen increase again? Think about it, I'll tell you in a minute. And here is a profile of a typical nutrient, which could be nitrate or ammonium and so on. So nitrate or ammonium or nutrient is lower in concentration at the surface because it is being used up for photosynthesis. Okay, and everything that's photosynthesized is eaten, and the zooplankton etc. die, or the phytoplankton dies and it falls down, and it is remineralized. Organic matter is converted back into nutrients, so the nutrients increase as you go below the euphoric zone, and you get a nutrient maximum which is much flatter than the oxygen minimum zone, because oxygen minimum zone is heavily used up by the living things, whereas the remineralization depends on many parameters, pressure, temperature, and so on. And you get slightly decreasing concentration of nutrients as you go below. So why does the oxygen increase again? You remember your thermohaline circulation. Where does the deeper water come from? It sinks from the surface. Surface water has higher oxygen. So it is the higher oxygen water that's constantly inundating the deeper ocean and increasing the concentration of oxygen in deeper waters. So you get oxygen minimum zone where the respiration and biomass is high, and then living things begin to decrease below. Physical controls on the dissolution increases, and physical transport from the surface increases, so oxygen increases. Okay, when you look at gases dissolved, you have to always remember that temperature matters, pressure matters. Remember your Coke can again, right? You keep the Coke or soda water or whatever aerated drinks cold because that keeps the CO2 inside, and you seal them because that keeps the pressure. When you open them, the pressure is released and the gases begin to escape. Or if you put that in the freezer and it freezes too much, then it can explode because of the freezing and release of the gases and build up of the pressure. Okay, good things to remember. Let me stop this here and come back to this section in the next podcast, because this already gotten a bit long, 7 minutes, 8 minutes. But nonetheless, just remember pelagic is split into epipelagic, mesopelagic, and bathypelagic. And you have, in terms of light, euphotic, good for photosynthesis, dysphotic, or coincides with the mesopelagic, and aphotic. Okay, we will return to the classification of the ocean zones again.